In our last section, we're going to learn how to create models for different types of function. The function we're going to focus on today is a linear function. So we're starting off with an example about population. We are told that it's growing at a linear rate, and we're given 2 points in time. So what we're going to do is take those 2 points and create an equation of a line based off of that information. Our first ordered pair is 2004 with a population of 6,200. Notice in part A, we're being asked to write the function for population in years after 2000. So instead of 2004 being my input, 4 is, because it's 4 years after 2000, and then the population is 6,200. If you remember hearing about independent and dependent variables, the population depends on the year, not the other way around. So that's why the year is our input and the population is our output. We'll do that again with the other piece of information we got. 9 years after 2000, the population was 8,100. When we start writing an equation, we need the slope. Slope, remember, is change in y. That little triangle is just a symbol that means change over change in x. So we have for our change in y, 8,100 minus 6,200. And for our change in x, we have 9 minus 4. Our change in y is 1,900. 9 minus 4 is 5. So that gives us a slope of 380. So to interpret that slope, the numerator was the change in people and the denominator was the change in years. So this town is growing by a rate of 380 people per year. Next, we can use point slope form to get the equation of the line. So we have the slope times x minus the x coordinate for either point you choose. I'm going to use the first one just because it has smaller numbers, plus the y coordinate of that same point. Distributing that slope and simplifying, we will get our equation in slope-intercept form. And we have a y-intercept of 4,680. What that y-intercept represents is the population in the year 2000, because that's what we called our starting point. Next, we can use that equation to answer a couple of questions. The first question is asking us to predict the population. The population was our y value, that was the output, that was our dependent variable, and the x value is our input, and that was our year after 2000. So we're going to substitute 13 for our x. And we end up with 9,620 for the population of that town in 2013. Our last question is asking when the population will reach 15,000. Again, the y value was our population, so we'll substitute that in for y, and this time we're solving for x. To solve for x, we subtract that 4,680 from both sides. We get 10,320. And to finish solving for x, we'll divide both sides by 380. We didn't get an exact answer, but it was very close to 27. Remember, that represents years after 2000. So in approximately the year 2027, the population will reach 15,000. And here's your U-Try question.